Text. The National Park Service collaborates with many other agencies and organizations to achieve its mission of preserving, quote, unimpaired the natural and cultural resources and values of the national park system, end quote. In Kenai Fjords National Park, scientists collaborate to better understand the nearshore ecosystem as part of the Gulf Watch Alaska program.
The Gulf Watch Alaska program is a long-term monitoring program that's designed to look at how the natural resources of our nearshore ecosystem are changing over space and time. It's fairly large scale, and it looks at sites in Prince William Sound, Kenai Fjords, Katmai, and a subset in Kachemak Bay as well, to develop a baseline and assess the natural variation in the resource communities, such as different algae and invertebrates, up to large predator populations that we see in marine birds and mammals like sea otters, sea lions, and whales. It's a monitoring program, so we're basically observing. We're not hypothesis testing, we're not experimenting. We're just watching, the natural environment and monitoring it to see how it changes. At each of these sites, they're visited annually, and in each area we have 5 sites. We're very focused in just the nearshore system and are trying to get a handle on what's happening at that interface where the land meets the sea. It allows us to look at not just, are there changes happening, but why might these changes be happening?
Coleman Bay.
This is the rocky site of the Nearshore benthic program. What we're doing is monitoring primarily how algal communities change over space and time, and we're also monitoring the different invertebrate species that play a critical functional role in the ecosystem, such as predatory snails that might consume mussels, or chitons that might graze down the algae, or limpets that provide an important resource for black oyster catchers and other nearshore inhabitants. So what we do at each of these sites is we have 2 transects that are laid out along contours, which have 2 very different biobands. And what a bioband is a different algal community, whether it's more like a brown and barnacle, mussel band you see across the shoreline, or one that's more like red algae and green algae. The transects that we sample at each and every site are permanently established. They came out here in Kenai Fjords and Katmai. The parks were set up in 2006, and so we've got almost 10 years of data now. And they're bolted with eye bolts that are mounted into the rock using anchors. And the transect is laid out the same way every year. And at each one, we have what are called quadrats, which are our little square sampling units that we place down. And we go point by point looking at all the algae that's encountered when we put this little knitting needle down. And it's kind of funny to use a knitting needle, but it allows us to sample these environments in an unbiased way. We drop the knitting needle at the crosshairs within our quadrat, and whatever is touching that needle, we call out. Echidodendron rock, fucus, Cryptosiphonia, Mastocarpus, Acrosiphonia rock. And so there's 25 points per quadrat. Here is our limpet line, where they're basically doing an expanding search pattern, counting all the limpets that they encounter until they get to 20 and measuring those 20 limpets. And then we can track how the size frequency of the limpets is changing over time. So you might expect if there's a lot of big limpets here at the site, it might mean that there's more biomass available for predators in the area. But if it's a site that has very few, or they're very small, there's less biomass.
7.
We also monitor for sea stars, which are important nearshore inhabitants. They consume mussels and other things. They provide food for other organisms. For that, we actually walk a 50-meter long, what's called a swath, where we're essentially searching for everything in a defined area that's 50 meters long and 4 meters wide. And we're counting all the sea stars and assessing their health. I personally find this project really just an inspiring and exciting one. There's a lot of power that comes from long-term monitoring studies. And, here in the parks, we've got almost 10 years, but this is also building off of almost 20 years of monitoring that's been going on in Prince William Sound following the Exxon Valdez oil spill. So it's continuing a legacy of understanding the ecosystem around us. And what we're finding is that we really don't know enough. You can come out here and say, this is what we're going to measure, but there's always things happening that are unforeseen. And it's going to be changing. The planet is always changing. It only goes in forward and it doesn't stop or go in reverse. And so knowing how things like, the effects of climate change or ocean acidification, or hopefully it wouldn't happen, but an oil spill happens again, or some other catastrophic event we would have a way to go back and say, here's what these communities look like, and here's what just natural cycles are. Here's what we think the perturbation caused. This Gulf Watch program is, intended to go on for at least 20 years. We hope for much longer, because the longer you watch, the more patterns you'll see, the stronger questions you can ask, and the better understanding, everyone will have of this environment.
John, I got your gloves.
Thanks, dude.
The biologist moves off along the water's edge, and the picture fades to black. Text: Major funding for Gulf Watch is provided by the Exxon Valdez oil spill trustees. Credits: produced by Katie Kritz and Jim Pfeifenberger. Videography and editing: Katie Kritz. Additional video and still images: Jim Pfeifenberger. Special thanks to Benjamin Weitzman, Heather Coletti, Dan Essler, and Benjamin Pister.